Chemical formulas. We represent compounds using chemical formulas, and this is just a shorthand of how many atoms of each element are in the compound. We use subscripts to tell us the numbers of each element. So H2O, the subscript after the element symbol, tells us the number of that atom. So H2O has 2 hydrogens and 1 oxygen. I think the chemists have a thing against the number 1, and you'll find that as we go throughout here. We don't write the number 1 unless we absolutely have to. So this isn't H2O1, it's H2O. I think we figure, if there wasn't at least one of those, I wouldn't have written the O. And if there's more than one, I'd write the number. So we just write this. If there's just the symbol, that means there's one of them. So here's another one, carbon tetrachloride, CCl4. Now you got to be careful with the I's and the L's and the 1's. Because is that an I, capital I, a number 1, or a lowercase l? Whatever you say, I could tell you you're wrong. And when we look at this guy here, I like this font, and yet this is one aspect of it I don't like, because the capital I's and the lowercase l's look the same. When I write things by hand, just a line is a 1, and I make my lowercase l's as a script L, and capital I's have the bars on the top and the bottom. And I would encourage you to do the same. When you see something like this, you kind of have to use some common sense. If this was CCI4, we wouldn't write it that way. We would write C2I4. So that must not be an I, that must be a lowercase l. This is carbon and 4 chlorines. So just watch out for those. They'll mess you up occasionally. There are different types of chemical formulas. Empirical, molecular, and structural. And we'll talk about them. The word empirical has to do with that we obtained it by experiment. It's not a theoretical sort of thing, it's empirical. We determined it in the lab. The empirical formula gives the relative number of atoms of each element in the compound. It doesn't actually necessarily tell us the number of atoms in a molecule. The molecular formula gives us the actual number of atoms in one molecule of that compound. So let's look at some examples, because that probably didn't make much sense. So if we have this compound, C4H8, this is a molecular formula telling us that one molecule has 4 carbons and 8 hydrogens in it. That's the molecular formula, the actual number of atoms of each element in one molecule. The empirical formula gives us a ratio, and it's like a fraction, and we're going to reduce the fraction. So the ratio here is 4 to 8, and there's a common factor of 4. And so we can reduce that to 1 to 2. So CH4 gives us the lowest ratio of carbon to hydrogen atoms. That's the empirical formula. It doesn't necessarily tell us the number of atoms in the molecule. For B2H6, that's the molecular formula. We can reduce 2 to 6, would become 1 to 3. And so the empirical formula is this. For carbon tetrachloride, CCl4, the common factor is 1, and so the ratio is still the same. Sometimes the molecular formula and the empirical formula are the same. If the ratio of these subscripts is not in its lowest form, maybe let's look at that as a fraction. So we've got 4 over 8. Right? That would reduce to 1 over 2. 3 over 6 could be reduced to 1 over 3. If we look at the numbers and they're not in the lowest ratio, it's definitely a molecular formula. And to find the empirical formula, we just reduce that fraction or ratio. If it is in the lowest, then it could be a molecular formula. We definitely know it's the empirical formula. Sometimes they're the same, sometimes they aren't. The structural formula gives us more of a clue as to how those atoms are actually connected to each other. And so we'll see something like this with lines connecting the individual atoms. The atoms are usually indicated by their element symbols. So this is hydrogen, oxygen, oxygen, hydrogen. This is hydrogen peroxide, and the formula is H2O2. Okay, so this formula, H2O2, is that a molecular formula or an empirical formula? It's a molecular formula, because the lowest ratio would be 1 to 1. That would be the empirical formula. This is a molecular formula. This is a structural formula because it tells us how they're connected. Because there's for some of these compounds, there's more than one way for them to be connected. Because you could imagine that maybe it would be connected like that. I mean, at this point in the course, why not? We'll learn later why, but that doesn't actually happen. But you could draw it. So we use these different kinds of formulas when they're convenient for us. It depends on the level of information we want to communicate and what we actually know. Structural formula gives you the most information. Empirical gives you the least. So those are formulas. Those are used to represent molecules. We also use models to represent molecules. There's different types of models. Ball and stick. This represents atoms as balls, and the chemical bonds are sticks. And this helps us to see how they connect. And this is usually a three-dimensional molecule and helps us to see the shape. The balls are usually color-coded to specify which element they are. This is not a universal color code, and you don't need to memorize it. But usually hydrogen's black, hydrogen's white, and carbon's black, and oxygen's red, and nitrogen's blue. We see this very commonly here. And then there are space-filling models. This helps us to see the overall shape of the molecule as it might appear if we scaled it up to visible size, which of course we can't do, but we could try. So here's an example of a molecular formula, a structural formula showing how those atoms are connected. This ball and stick shows how they are arranged in three-dimensional space, and this gives us an idea of how the molecule might actually look. Here's another table that might be helpful if you're trying to figure out all these different things. Name, empirical formula, lowest ratio. So here, benzene. The molecular formula is C6H6. The empirical formula is the lowest ratio, which is 1 to 1. Acetylene also has the empirical formula of CH, but it has a different molecular formula. This shows how the atoms are connected and what kinds of bonds connect them. Here we've got single bonds and double bonds. This is a ball and stick model, and this is a space-filling model.